Let's talk about defenses. How do you stop the network itself being overwhelmed? One thing you can do is try and filter out packets that are part of the attack. So somewhere in the network, maybe it's at a router, or maybe it's at the server itself, we can add a piece of code that checks all of the incoming packets, keeps the ones that are part of legitimate traffic, and discards all of the other ones. How do you know what packets are part of the attack and which ones are not? Once again, that can be kind of hard. If there's just one attacker, maybe you can just check the source IP field. And if the packet is coming from the attacker's IP address, then you drop that packet and you ignore it so that it doesn't bother the server or any later network component. That might be something you can do. Or maybe if there's some sort of pattern to the attack, then you can try and notice that pattern to distinguish packets. So maybe the attacker has always used this specific input to attack you. They always send you the bad list that causes the sort to do something bad. Then maybe you can find some pattern. Notice that everyone sending you the bad list of numbers on purpose is probably doing so because of an attack, and drop their packets. So the packet filter can do different things, but the goal is usually to distinguish legitimate traffic and attack traffic. Now, the packet filter, just like anything else, has limited resources. So once again, we have to make sure that people can't overwhelm the packet filter. An attacker might be able to send so many packets that the packet filter itself cannot keep up with reading every single packet and deciding which ones are legitimate and which ones are not. There are some other ways that attackers might subvert a packet filter. If they spoof their packets so that they're not coming from just one source IP, but many different IPs, then we no longer are able to use IP addresses to filter packets because the attack packets are coming from all sorts of different IPs. This makes the packet filter's job harder and is an advantage for the attacker. How do you defend against this? A lot of modern networks will stop you from spoofing. So if they notice that you're sending a packet and it doesn't match your IP address, they might block the packet from being sent any further. That could be one way to stop spoofing attacks. Now notice that this attack can happen whether there's one attacker or many in a DDoS attack. Even if there's one attacker, that single attacker could still possibly spoof their packets and lie and say that they're coming from all sorts of different locations, even though they're just coming from one attacker. And the goal here is to subvert the packet filter and make its job harder. Now, another possible attack is to use actual DDoS, where you are sending packets from many IP addresses. So here you're not doing any spoofing at all. Every packet is honest, but they're really coming from dozens or hundreds of different sources. So this shows why DDoS is so hard to defend against. The packet filter has to think a lot harder about packets to try and figure out which ones are part of the DDoS attack and which ones are not. And just like with application-level DoS, you can still stop network-level denial of service by over-provisioning. Go out to the store and buy as much bandwidth and networking equipment as you can possibly get with the amount of money that you have, and that will make it harder, although not impossible, for attackers to overwhelm your network. So having a lot of network capacity and a lot of redundancy is what a lot of modern services use to stop denial of service attacks.